Solving quadratic equations by completing the square. So what do we mean when we say completing the square? What is this square? I've done some demonstrations with tiles, algebra tiles, if you've been in my class. But let's just talk about what is a perfect square trinomial. What's a perfect square? Perfect square is 1, 4, 9, 16, 25, 36, all that sort of stuff. So a perfect square trinomial is where we have a square in the front and a square in the back, and the middle term is 2 times the square root of each of those. So that's a perfect square trinomial. That's a perfect square trinomial. That's a perfect square trinomial. And I'm only giving you ones with a's of 1 because I don't know the other ones off the top of my head. And really, these are the kind that you need to really be able to look at in terms of, completing the square. Because even when we have trinomials with larger coefficients, these are always going to be what we're heading for within the course of the problem. And so I'm going to leave that off to one side, and then I'm going to do a super quick, how would you solve an equation like this? We did some like this, and we say, well, that's ready to take the square root of both sides. Don't forget your plus and minus. So you'd have x plus 8 equals plus or minus the square root of 10. Subtract 8. So this is just solving a quadratic equation, an equation with an exponent of 2 by taking square roots. So what we're going to do is we're going to put those two skills together, knowing what a perfect square trinomial is and solving by taking square roots, and that's how we're going to solve by completing the square. Because really, let me go over to the left-hand list one more time. Let's see, can I do this really fast? Yeah, x squared plus 16x plus 64, that can be factored to. Right, so here's a quadratic, x squared plus 8x plus 10 equals 0. Now I could try to factor that, but I'll tell you right now it's not factorable. I could use the quadratic formula, but I'll tell you right now I'm not going to do that till after I teach you completing the square, because they're related. And so we're going to use completing the square on this. And what we mean by completing the square is we want the left side to become a perfect square trinomial. So we have x squared plus 8x. I don't want that 10 there anymore. I want to get a new c. So actually I'm going to go back here, and I don't want to take up a lot of room. So I'm just going to sneak this in here. I'm going to move the old c out of the way and move it to the other side. So I'm going to get a new c. And if I'm going to add something to the left side, I'm going to have to add it to the right side as well. So I'll sometimes refer to this as get a new c, because we're going to get rid of what we don't want and we're going to put in what we do want. So why did we do that? Well, in order to make a perfect square trinomial on the left, I'm going to go back to the top and remind you that a is 1, b is 8. I'm not going to worry about the c because we got rid of it. We're looking for the c that will turn that left-hand side into a perfect square trinomial. And so what we're going to take is we're going to take b over 2 and square it. In this case, that's 8 over 2. And I'm going to make a kind of point of making sure you pick up that sign. It's 8 over 2 squared, which is 4 squared. And I know it's silly that I'm writing that plus sign, but I'll show you why in a minute. And so it's going to be 16. So this is my new c. And that's going to go added to both sides. I really just want it on the left because that's going to get me a perfect square, but I can't just do something on the left and not do it on the right. My equation wouldn't be equal to itself anymore. So now that I have a perfect square trinomial, I'm going to factor it. And now it's just that easy to factor. That's why we like completing the square, because if it's one that fits into the kind of the pattern that I would do this on, it's very easy. I wouldn't do this to just any quadratic, and we'll talk later about which ones would be good. I didn't put that as one of my recap questions. I probably should have. So how did I get that x plus 4? I hope you can see that by now. I hope we've been doing enough factoring and solving and looking at things in standard form and vertex form and intercept form that you see where that came from. But I'll talk about it in a minute. So now what do we have left to do to solve it? Well, we're just going to take the square root of both sides, remembering our plus and minus. So now I've got x plus 4 equals plus or minus square root of 6. And I only have one more step on this one to get x alone. Negative 4 plus or minus square root of 6. Now, if that 6, if there was something underneath the square root sign that could be simplified, we'd have more steps. If there was a negative under there, we'd have to take out an I. If I had anything with perfect square factors in there, I'd have to deal with it. If I had any fractions going on, I'd have to deal with it. But this was kind of the simplest case to do this on. And that's what our answer looks like. If we were going to graph it, we could get a decimal equivalent for that square root of 6. And we would have x-intercepts. These would be our x-intercepts. But they're not going to be integers in this case. So before I do another example or before I write steps, let's talk about how did I get that x plus 4 so quickly? Look at where it came from. I hope you saw where it came from anyway, but it's just whatever we got in there before we squared it. So there's a little trick for you. That's why I wrote the plus sign, so you see it's that same plus 4 plus 4. Okay, now all the steps I'm going to write are only when a is 1. I'll do an example or two for you when a is not 1, but I want to make sure you know that these are the steps when a is 1 only. Let's make that a lowercase a. Because when a is not 1, there's some extra stuff to go on. So what did we do first? Okay, so we step 1, let's not say get rid of, let's say move old C to the other side. This is assuming it's in standard form. Step 2, get a new C. By using b over 2 squared. Step 3, add it to both sides. Step 4, we're going to put the left and the right work both in step 4 because I always do them at the same time. So step 4, factor the left, right? It's going to be a perfect square trinomial. And you're always going to have two things to add together on the right, so simplify the right. That was our negative 10 plus 6. After that, take the square root of both sides. Don't forget your plus and minus. Step 6, add or subtract to get x alone. Now that's all we had to do on this one. I'm just going to put a note at the bottom. Make sure to simplify the radical if you can. Because if you have a perfect square underneath there or a fraction underneath there, that'll happen sometimes. You've got to make sure that you do all the rules to simplify that. Or if you have a negative number under there, you could have to pull out an I, stuff like that. So there's a beautiful example. We'll do one that's a little more complicated next. We've got x squared plus 60 equals 12x. So the first step is to put it in standard form. And I say that, but really if the c was on the right, we would leave it. We definitely have to move the b term, the term with the x, over to the left. And so a step along the way, it's going to be in standard form. But the very next thing I'm going to do is get rid of the old c to make room for a new c. So we've got x squared minus 12x plus something that's making our room for our new c equals negative 60 plus that same something. We're going to have to add it to both sides. And I write those blanks because I know one thing that I often forget is to add it to both sides. So my habit of writing those blanks on both sides remind me I can't just slap something on the left and not have it change the equation. I have to put it on the other side to balance it out. So we're going to get our new c, b over 2 squared negative 6 squared, which is 36. So this number here is what's going to get added to both sides. So I've got the left factors nicely, x minus 6 squared. Remember the shortcut. I hope you could get it without looking at it, but we got that negative 6 from over here equals negative 60 plus 36 is negative 24. And so this time when I take the square root, I'm going to have a negative number. So I know there's going to be an I as part of my answer. The square and the square root cancel. So I'm still going to go through once writing negative square root of negative 24, just so I see that there. X minus 6 equals plus or minus. Now, I don't just have an I that comes out. I know I have an I that comes out that takes care of the negative. And I hope you can do these without going through the work, but let's see one with the work just because maybe it's been a while. So I've got 2 times 2 times 2 times 8. 2 2's make 1 come out. That's not an 8. That's a 3. So a 2 comes out, and so we end up with 2 root 6. And the last one, I'm going to squeeze it down here vertically. We're going to add 6. It's not a like term with anything, so we just end up with 6 plus or minus I 2. We like that the other way around. 2I square root of 6. So there's my answer. Okay, so that one, when we couldn't graph it, in the or we wouldn't have real roots, I should say.